To a science video test review. Today we are going to be talking about metamorphic rocks. Now, metamorphic rocks are formed from two basic ways: by pressure and by heat. Heat and pressure actually changes the way that a rock looks. It changes its physical properties, the way that it, once again, looks in how it is made up. So one of the examples that we talked about in class is a dog pile. I don't know if you've ever been in a dog pile, but I know when I was little, we would go dog pile, and then everyone would kind of jump on one another. You're not really allowed to do that nowadays at school, but it was always kind of fun. Everyone would be like jumping on top of one another, and if you were at the bottom, you felt all this pressure. You were squished. Okay, so you were tighter than normal. And also, after a while being at the bottom of this pile, you started to get hot. Okay, so you started to feel the heat. You started to feel the pressure. You're being squeezed together. Well, that's the same thing that's happening with these different layers of rock. Okay, so you have the crust here. This crust is moving this way. This crust is moving this way. Okay, so this one's moving this way, this crust is moving this way, and they are actually rubbing against one another. Okay? And in class we talked about when you rub your hands like this, it starts to get hot. Okay? So you have these moving plates that are rubbing against one another, creating heat. You have all these different layers of sedimentary rock that start to pile up on top of one another. And so at the bottom here, it starts to, once again, start to feel this heat and pressure like the bottom of a dog pile and the rubbing of the friction that's going on down there. So what happens is, deep below the Earth's surface where you have this heat and pressure, because it gets so hot and all this pressure, it actually starts to mix. And this, like we talked about in the last lesson, I believe, and we were talking about igneous rocks, or that may have been the first lesson on the rock cycle. You have igneous rocks. Igneous rocks are formed from this magma, okay? So you have this magma that's deep below the Earth's surface because of the heat and pressure. It actually starts to mix. Now, this granite igneous rock that's mixing underneath all these different layers, you can see how all of the colors, the different soil that is underneath the ground, right? It starts to mix and blend, and when it cools, it can turn into a metamorphic rock called gneiss. One of the ways that you can tell that a metamorphic rock is gneiss, is by these colored bands. And it got these colored bands because of the mixing that was going on from the igneous rock by being below the Earth's surface with the heat and pressure. So gneiss is a metamorphic rock that comes from an igneous rock called granite. Okay? Let's see here. Another popular metamorphic rock that we're going to talk about is a metamorphic rock that comes from sediments. Okay, we've talked about this before. In the ocean or in the air, sediment rock is created when a whole bunch of sediments, either by the ocean moving it to one area or by the air moving it to one area, it all starts to pile up into one area. In our example on the whiteboard here, the ocean is moving these sediments to one area. So all of the sediments start to pile up against the shore here. We have it piling up underneath the ocean. And so you start creating these layers of sedimentary rock. Well, because like I talked about earlier, the crust is moving, it brings this sedimentary rock into this magma where it starts to blend and mix. Okay, so the sedimentary rock moves because the crust is moving, and it starts to blend in with some of the heat and pressure mixing that's going on down here. So one of the metamorphic rocks that comes from sedimentary rock is marble. Marble kind of has this rough texture. Why does it have this rough texture? Because it was formed from all these bits of tiny pieces of sedimentary rock. So it has this rough texture. You can see it's kind of coarse. You can see all the little teeny pieces in there. And marble is used to make statues. It's smoothed out and they make really nice. Let's see. The other type of metamorphic rock that we're going to talk about is quartz. Now, quartz is a metamorphic rock that came from sandstone. Sandstone is formed at the bottom of oceans from tiny little bits of fossils. Fossils are like dead organisms, kelp that has died, and that sort of thing. It all starts to pile at the bottom of the ocean. Okay? Now, this sandstone, all these little bits, they start to pile up on top of one another. So this layer used to be the layer that was first in line at the bottom of the ocean. But then different layers started piling on top of it, and so now this layer is at the top. But this layer down here used to be the top layer. Okay? So this is a sandstone here. It's made from, once again, the dead organisms and anything else that has fallen from the ocean. Now, once that sandstone starts getting mixed up also from the heat and pressure, it can turn into quartzite. Now, quartzite is glassy, it's very hard, and one of the things that we use it for, people, is tile and glass. So once again, a sandstone rock gets turned into a metamorphic rock called quartzite. Alright, let's see here. I think that is pretty much it. And just by way of review, what are some ways, how do we tell what kind of rock it is? Well, we can look for clues. We can look at the color, we can look at its luster, whether it shines, we can look at what kind of break it has. Does it have a cleavage, which is nice and straight? That means that atoms are nicely lined up in rows. Or does the rock break in a fracture? What this means is all jaggedy all over the place. That means the atoms were not nicely ordered. They were all over the place. What about, let's see, we talked about luster, we talked about cleavage and fracture. What about streak? What kind of powder is left behind when you scratch it? What about the Mohs hardness scale? By trying different rocks, you can see how hard a rock is. These are just some of the ways that we can figure out what kind of rock it is. So, for example, if I'm a scientist and I find a rock in this area and I look at it and it's kind of rough, it has a whole bunch of pieces, I can say, oh, it's probably marble. It came from sedimentary rock and it got mixed in here with the heat and pressure. It's a metamorphic rock. Or maybe I look at it and I see the color bands and I find it deep within the Earth's crust. I'm like, oh, that's a metamorphic rock that came from igneous granite. I can see the color bands. That must be nice. Or maybe we are looking at below the ocean and we dig down a couple layers and we know that it's, we see that it's glassy, we can see that it's very hard, and based upon the clues, we know that it's quartzite because of where we found it, what it looks like. It's very hard, it's glassy, and that sort of thing. Well, this is metamorphic rocks. Once again, metamorphic rocks are formed from heat and pressure. I hope you've enjoyed this lesson, and I think you guys will do awesome on the test, and I look forward to seeing you guys in class.